In this section, we will look at the engine block and related components. Additional material has been added to the block casting and more webbing has been added to improve the strength of the block. The V of the block is set to a 60-degree angle. The handhole covers have been changed to round openings to improve the strength of the block. Each of the 140mm openings is sealed using a cover plate and O-ring. The QSK 45 and 60 block castings are 6.2mm longer than KV engines. Due to the increase in the camshaft bores, the cylinder block width increased. The block includes integral fuel timing and metering rails. The block has been redesigned to improve the coolant flow around the cylinder liners. This design results in a counterbore depth of approximately 13.7mm. The fittings in the block utilize straight thread O-ring metric fittings for better sealing capability when compared with tapered pipe thread fittings. The engine has replaceable cylinder liners. The liner has increased in length over the previous KV liners to accommodate the longer stroke. The lower press fit area under the liner flange locates the liner in the block. Centering tabs on the brass sealing ring align the ring on the liner. This ring installs between the liner flange and the block counterbore to provide the upper coolant cavity seal. A crevice seal and two D-shaped rings install on the liner. The crevice seal and the middle black ring provide the lower coolant cavity seal. The bottom red ring prevents the oil from migrating into the coolant around the liners. The crankshaft has a 184mm crankshaft nose. This larger nose improves the front power takeoff capability of the engine. This also makes the front crankshaft nose and the rear crankshaft flange the same diameter. The main journal has been increased by 19mm and the rod journal has increased nearly 12.7mm over KV engines. The main caps are all the same width and are located by dowel rings. The caps are matched to each of the bearing saddles. The thrust bearings are held in position by roll pins on the side of the number 8 cap on the QSK 60 and on the number 6 cap on the QSK 45. Each of the caps are held in place by 4 cap screws, 2 that install through the cap and into the block on each side of the saddle, and 2 that install through the side of the engine block and into the side of the cap. All of the cap screws are installed using the Torque Plus turn method of tightening. Refer to the service literature for the appropriate installation procedures. The main caps are torqued using the Torque Plus turn method of installation. The main bearing cap screws are torqued to specification first in the sequence shown in the service literature. After all of the main cap screws are torqued, the side cap screws for the right bank are torqued first, and then the side cap screws for the left bank. The articulated pistons feature an aluminum skirt for weight reduction and a forged steel crown. The steel crown allows the piston to better withstand the increased mechanical and thermal loading of the engine. The steel crown also allows for a higher top ring position and has an integral oil cooling gallery. With a steel crown and isolated piston skirt, the piston-to-liner clearance can be reduced, which results in less liner movement and minimal cavitation. The piston pin bore diameter has been increased. Bronze bushings in the pin bores improve thermal resistance and load-carrying capacity. The assembly now uses a hollow piston pin to reduce weight. QSK 45 and 60 pistons use a conventional 3-ring pack design. The top ring is cast iron using a keystone design with an inlaid chrome face. The intermediate ring is made of cast iron using a keystone design with a tapered full chrome overlay face and a positive twist. The bottom or oil control ring is steel using an eye cross-section design and a coil-type expander. 5mm oil drain back holes in the piston oil control ring groove allows oil to return to the oil sump. The split-angle design connecting rod provides for easier installation and removal. The matched rod and rod cap assembly uses dowel rings for alignment. The serrated rod to cap mating face provides for additional clamping surface. The 320.6 millimeter rod is 31¼ millimeters longer than the KV rods when measuring between the center of the rod bores. 4 cap screws hold each of the connecting rod caps to the connecting rods. The cap screws install using the torque plus turn method of installation when the engine is not installed in chassis. However, when the engine is installed, the two-step torque sequence can be used. The pin bore bushing is splash lubricated by piston cooling nozzle spray. 2 piston cooling nozzles for each cylinder spray oil to lower the piston crown temperature. The galleries in the piston direct the flow of oil from the nozzles across the piston to provide improved cooling. The block stiffener plate mounts to the engine pan rail. The plate provides additional strength to the block. The QSK-60 utilizes 3 breathers. They are located on the mid-left side, left rear, and right front of the engine. Each breather has a drainback hose connecting to a crankcase handhole cover. The blow-by sensors install on the breather tube. The cam followers and shafts install on the side of the engine block over dowel rings. The increased shaft and bore diameter and injector roller width are needed for durability with the higher injection pressures. The shafts have a lubrite coating for improved shaft wear characteristics from contact with the parent bores and the cam followers. The pin holding the micro-finished complex crown rollers and the followers must be frozen in liquid nitrogen prior to installation. Due to this tight press fit, the cam follower rollers are not serviceable in the field.